Hello guys, this is Himanshu and we are continuing with our binary tree module. So today we are going to discuss about in-order traversal by using iterative method. So in the previous video we discussed the in-order traversal by using the recursion. So today we are discussing it by using a iterative method. So let's first uh, see again how the in-order traversal works. So in-order traversal, first we have to explore all the left nodes. Then we have to explore the root nodes and then we'll explore the right node. So let me change again the pointer. Okay, so let's write the in-order traversal for this particular tree. So first we'll explore all the left node. So for 1 the left node is 2, for 2 the left node is 3, for 3 the left node is null, so we'll print 3, and there is no right node for the tree 3. Then we'll go back to 2. We have explored the left node for the 2, so we'll print the value of the node, and then we'll go to the right of the 2, so which is 4. Then we'll again go to the left of the 4, which is 7. Now 7 do not have anything in the left, it's null, so we'll print the value of this node, which is 7. Right also is null, so we'll go back to 4. Now we have explored the left of the 4, so we'll print the value of this node. Then its right is again null, so we'll go back to 2. Now we have explored everything left, the value and the right of the 2, so we'll go back to 1. For 1 we have explored the left part, so we'll print the value of this node, which is 1. Then we'll go to the right. Here we'll come at 5. Now 5 has left node as null, so we cannot go further on the left, so we'll print the value of this node, which is 5, and then we'll go to the right of the 5, which is 6. For 6 again the left node is null, so we cannot go traverse on the left, so we'll print the value, which is 6. And then again there is nothing in the right for this guy, so this is explored. For this guy also the right, left and the value is explored, and for 1 also the right part is also explored, right? So this is our complete in order traversal. Okay, so now let's go ahead and see how we can implement this particular in-order traversal by using the iterative method. So before going into this, many people have asked me in the comments that why the videos are 30-minute long. So what I try to do, I try to simulate the whole interview process where you are given a problem. You will first try to explain your solution to the interviewer, and then you will do the go into the coding part. So I do the live coding just to explain you like how you are going to code in your interview. While writing your code, you have to explain what are the different things to your interviewer. So it's a complete simulation of the interview process. So that's why this channel is completely different from the other channels where people will write the code before and they will just go through line by line and will try to explain you the code, but it will not give you the complete exposure, and then you go into the interview and while writing the code you get stuck somewhere. So and the other thing, in most of the YouTube channels, what I saw, like they will start with the problem and then they will say, okay, we'll go ahead and use the this data structure to solve this problem. They never say or tell us why we are going to use this data structure, or what was the procedure before choosing this data structure, like why are we even choosing it and why are we solving this problem in this particular manner. So these are the two problems that I'm trying to tackle by using this YouTube channel, because when I started my learning I faced like basically these are the two problems while I was going through the different YouTube channel and trying to learn from those channels. Okay, so let's go back to our problem again. So in order traversal we have to solve iteratively. So what does in order traversal say? First we have to explore the left part or left node, then we will print the value of the node, right, and then we'll go into the right part. Okay, so if you see here, um, so we have a way of going down into this tree data structure because we have the link which is like 1 is pointing to 2 and 2 is pointing to 3 and 3 is pointing to 7, right? And when we reach 7, there is no other way for us to go forward, right? So at this point we print the because left is null, so we print the value of this node, right? And then we'll go to the right to explore the right node, right? But when you reach at when suppose you are at this 7 node, you came back, you came down because you have the references here. When you reach here, you printed the value of this node. Now you have to go back. There is no way for you to go back because there is no reference which is pointing to the node which is on the top level, right? So what we have to do, we have to store the nodes while we are coming down our tree, right? And the other thing that we have to notice here, after printing the 7, we what node we have to get, which we inserted before 7, right? So if you see it closely, this is actually a problem where we have to get the node which we inserted recently, right? So suppose we are inserting 1 2 3 7, and then we have to get the node which is recently inserted, and then we have to get the node which is previously inserted before the recently inserted node, right? So this is a typical case where we can use the data structure which is stack, right? Because stack is last and first out data structure, right? So that's why we have to use the stack. First we have to store the elements, and then we have to, when we are getting the elements back, we have to get the elements in the last in first out manner, right? So whatsoever was inserted recently, we have to get it first. Cool. So so we'll use stack to store our data. Okay, I hope now this is clear why we are using the stack as a data structure. So let's write our, okay, so now, okay, now let's draw a stack. So, okay, so let's start from here. So what we were doing here, we were first exploring the left. So one's left node is 2, two's left node is 3, three left node is 7, right? So while we are starting from here, we'll start putting elements into the stack, because when we are coming back from here, we have to get those elements back, right? So we have to store it. So first we stored 1, then we stored 2, right? 2 also have the left element or left node, so we'll store the left node again. This also has the left element which is 7, so we'll store the left element again. Now this has the left element which is null, right? So here our, we cannot go back further, right? So we will pop the first element which we are getting from the stack, so which is 7. So what we'll do, we'll first print the value of this node, and so just remove this node from the stack because we popped it. Now what we'll do, we'll check if we have any element on the right of this particular node which is null, right? So we don't have anything. Okay, so now we'll get the next element from the stack which is 3, right? So first we'll print the value of this node, and then we'll again check if there is any element which is on the right of this node which is not, again, like there is no element, right? So we will pop the next element from the stack which is 2. So first we'll print the value of the node, and then we'll check if we have any element which is on the right of this node which is 4. Okay, so we'll insert 4 here, then we'll check if it has any element which is on the left, right? So there is nothing, right? So we'll stop here, then we'll again pop the top element of the stack which is 4. Now we will check if there is any element on the right which is not there. So so there is no element on the right. So so as this node is completely explored, we will take another element out of the stack which is 1. So we'll remove 1 from here. We'll print the value of the 1, right? And then we will check if there is any element on the right of the 1 which is 5. So we'll put 5 here, as the 5 left is nothing is there on the 5 layer, so we cannot explore in this direction. So we'll pop out the element from the stack again, which is 5. So we'll print the value of the 5, and then we'll explore the right side of 5, which is 6. So we'll put 6 here, as there is no element on the right side of the left side of the 6. It's null, so we cannot proceed further. So we'll pop out the element from the stack again, which is 6. We'll print 6, and then we'll check the right side, and there is no element on the right side of the 6. Now we'll again check, and there is no element into our stack as well. So we'll end our program, and this is our in-order traversal. Okay, so now uh, let's check how much space are we going to use. So as we can see here, we are using stack, and the number of elements which will be in this stack in the worst case scenario will depend upon the, because we are traversing into the depth, right? So it will depend upon the height of the tree at that particular moment. So whatever will be the height of the key will be the height of the, or the space, or the number of the element which we are going to store into the stack. So our space complexity of this program will be O of the height of the tree, right? And what will be the time complexity? As we can see here, we are exploring all the elements which are present into the, which are present into the tree, right? So we are going through all the elements one by one. So the time complexity will be O of n, where n is the number of elements in the tree. Okay, so I hope now you guys understood how the iterative and order traversal work. So now let's go ahead and write the code for the in order iterative traversal, or in order traversal, by using the iterative method. Okay, so this is where we left our ID in the last video. So we wrote the level order traversal in the last video. Okay, so let's go ahead and write the program for in order traversal iterative. Okay, so we'll pass the node root as an argument. Cool. So first of all, again we'll check if the root is null. If the root is null, then we have nothing to explore, so we'll just return. The root is not null, so what we'll do, we will, as we already know that we have to use stack, so let's go ahead and declare a stack here. And stack will contain the, it will store the node of the tree. So let's stack. Cool. So now we have a stack. We'll need one more variable which will be holding the node that we are executing, initializing it with root. Okay, so now let's write the code. So until the stack has any element, we'll go ahead and what we have to do then, let's go back to this. Until the stack has any element or our node is not equal to null, right? because initially we have a stack has zero element but node is not equal to null, so to enter it, right? Okay, so what we have to do here, what we have to do, we'll start from here from 1, and then we'll keep on going into the left or the left or the left, right? And we'll keep on inserting the element into the stack. This is what we started, right? We first put 1 and then put 2, then 3 and then 7, and then when the next element is null, we pop the first element from the stack, right? And we print the value, which is 7. So let's go ahead and write it. So if our node is not equal to null, what we have to do, we will add the element into the stack, and after that what we have to do, we have to explore the left. So we'll just make node the node of left. Okay, and when our node is null, which will be when we'll reach the 7, right? So 7 left is null, so node will become null. So in that case what we have to do, what we used to do, we used to pop the element from the stack and print its value, right? So let's do the same here. Let's pop the element which is on the top of the stack and then print its value. Then print its value. Cool. So okay, let's print the value. So here we printed the value, and after that what we were doing, then after printing the value, what we have to do, we have to go to the rights, right? So what we were doing, we were exploring the right. So let's do the same thing here. Make node equal to nodes right. Okay, so now node is node right, then it will again go back, and when the right is not equal to null, it will again explore the left. If the right is equal to null, it will pop the next element from the stack and it will print it. Okay, so yeah, that's all for the iterative in-order traversal. So pretty simple code. Now let's go ahead and check if this code works. So let's go to our program. Okay, let's comment this part. Okay, now what we have to do, we have to first create our tree. Let's create our tree. So the root is 1, then roots left is 2, root right is, let's check what was the root right. So root right is 5, and then left is 3, left right is 4. Okay, 5, left is 3, left right is 4, then left left is 7. Okay, and what we have to do, we have to do right which is 6. Cool. So now we have our tree ready. Now let's use our traversal util and call the function that we wrote just now. In order traversal iterative, pass this as a root. Now let's run and wait for the output. So now let's compare the output that we got with the output that we discussed. So 7 3 2 4 1 5 6. So this is the right output for this particular tree. So our in order iterative traversal works. Okay, so now let's go back to our code and let's go back to our code. Okay, and let's put it side by side with the thing that we discussed. Okay, right. So yeah, now let's run it. So we'll start from here at 1. So initially we'll put 1 into our stack. This is what we are doing here. So node is equal to root, node is not equal to null. So we'll come here, node is not equal to null. We'll push the node into the stack, which is the root, and then we'll move to the left. So we'll come here, right? After this, what we are doing, we'll again come here in the while, and node is not equal to null. So we will come here in if condition node is not equal to null. We'll go back here and we'll push the node again into the stack, so which is 2, and then we'll move to the left of the 2, which is 3. This thing will keep on going. We'll put 3 also, then we'll put 7, and then at this point this node will become null because the left of the 7 is null, so this will become null. We'll come here. In this case the node is null, but the stack has 4 elements, so stack count will be greater than 0. So we'll come back here. Now the this if condition will be false, so we'll come into the else. Now in else what we are doing, we'll pop the element from the stack. So we'll pop 7 from the top of the stack. Okay, then after that what we are printing the node data, right? So uh, just 1 minute. So yeah, so if you see here we printed 7. Okay, now what we are doing here, we are making node equal to node right. So we are at 7, so 7 right is null, so node will become null. We'll go back here again. Our stack has 3 elements, so count will be 3, which is greater than 0, but the node is equal to null, so we'll go into the else condition. Then we'll again pop up the next element, which is 3. So let's remove 3. Then we are printing 3 here, so we'll print 3 here. Okay, and then we'll say node equal to nodes right. So 3 night is null, so again node will become null. So we'll come here, node is null, but the stack has 2 elements, which is, so 2 is greater than 0, so we'll continue our while loop. Again node is equal to null, so we'll come here, we'll again pop the next element, which is 2. We'll print the value, and then we'll say node equal to nodes right. So 2 right is 4. Okay, so our node will be pointing to 4. So this is our node which is pointing to 4. Then we'll come here. This time this condition will be true, our node is not equal to null. So when our node is not equal to null, we'll push the node into the stack. So we'll push 4 here. We'll say node equal to node left. So fourth left is null. So again our node will become null, right? So we'll come here, but our stack has 2 elements, so count will be 2, which is greater than 0. But our node is null, so we'll come back here. Now what, when our node is null, what we'll do, we'll again pop the element of the stack. So we'll pop the element which is 4. So we'll after this we will come here and we'll print 4. Then we will say node equal to node right, so which is again null, right? So our node will again become null when so this condition will be false, but our stack has 1 element, so our stack count is 1, which is greater than 0. We'll continue the loop. Now our node is null, so we'll come back here. What we'll do, we'll pop the next element from the stack, which is 1, right? So we'll print 1, and we'll make node equal to node right. So 1 right is 5, right? So our node will be 5. So we'll come here in this while loop. Our node is not equal to null, so we'll continue the while loop. If condition will also be true, our node is not equal to null, so we'll push the node into the stack, which is 5. Then we'll say node equal to node left, which is null. so our node will become null in this case. We'll go back here, this condition will be false, but our stack has one element. So we'll continue the while loop. This condition will be false. So we'll come into the else. Now we'll make node equal to, so we'll pop the next element from the stack, which is 5. So we'll pop 5. So we just pop 5. We'll print 5 here. And then what we'll do, we'll say node equal to nodes right, which is 6, right? So our node will point to 6 now, right? So we'll come here, our node is not equal to null, which is true. If condition will also be true, node is not equal to null. So we'll push the node into the stack, which is 6. Then we'll say node equal to node left, which is null. So our node will become null. Then we'll come back here, this condition will be false, but our stack has one element. So we'll continue the while loop. Again, this condition will be false because node is null. So we'll come back here, we'll pop the element from the stack. So 6 will be popped from the stack. We'll print the value of the node. So we'll print 6. Then we'll say node equal to nodes right, which is null. So node will again become null. In this case, we'll again come here. Now our node is null and the stack also do not have any element. Our stack is also empty. So this loop will terminate. So what we have done, we have printed the in-order traversal of our tree. So I hope now you guys understood how the in-order traversal works and how we can go ahead and write the code for the in-order traversal iteratively. If you haven't subscribed to my channel, please go ahead and subscribe. If you like the video, please go ahead and press the like button. If you have any confusion, please put it into the comment. I will reply. And I hope you enjoyed watching this video. Thank you.